This is an optimization problem. There's a company by name Giapeto, which manufactures two types of furniture, chairs and tables. The manufacturer wants to maximize their weekly profit. Let X1 units of chairs and X2 units of tables are produced. So $20 per unit of X1 and $30 per unit of table is a profit. So this is total profit, and the manufacturer wants to maximize it. This is called objective function. Next, a chair requires 1 hour finishing labor and 2 hours carpentry labor. So 1 hour finishing labor and 2 hours carpentry labor is required. So 1 hour finishing labor and 2 hours finishing labor. 1 hour finishing labor for chair, 2 hours finishing labor for table are required. Total available work hours are 100. Similarly, 2 hours carpentry labor for chair, 1 hour carpentry labor for table are required, and total available time is 100. So these are constraints. Subjected to these constraints, we'll have to maximize the profit. So let us solve it using a module by name pulp. So from pulp, import all methods. Okay, but the name of the problem is, say, optimization, or say name of the problem is problem itself. Problem is a linear programming problem. Problem should have a title, and the title is, say, fabrication. Title is fabrication. The type of problem is maximizing problem. It has two variables. One is X1 and second one is X2. Say X1 is a linear programming variable. Name is X1. Its lower bound is 0 because number of chairs can never be negative. Its category is integer. Similarly, X2 is also a linear programming variable. It is X2. Its lower bound is 0, and its category is integer. Number of chairs can never be fractional, or number of tables can never be fractional. Now add constraints to the problem. So problem equal to problem plus, first constraint is my optimum function. See, the objective function is 20x1 plus 30x2. So add it, 20 into x1 plus 30 into x2. Now next add the constraints. Constraint 1, what is constraint 1? x1 plus 2x2, and the other one is 2x1 plus x2. So x1 plus 2 into x2 is less than or equal to 100. So next constraint is 2 into x1 plus x2 less than or equal to 100. Okay, so print problem. Let us see whether the problem is created or not. There is some spelling mistake. Let us correct it and run it. So save it in EX and run it. So problem is found. 20x1 to 30x2 is objective function, then constraints, then lower bounds. Now, so solve the problem by using the method solve. Now, if the linear programming status problem status is optimal, then print the results. First, number of chairs, so which is x1, so value of x1. Okay, next print number of tables, which is x2, number of tables, which is say x2, so value of x2. Next, and you get floating point values and make them integers. Fine. Next, print say total profit. This is int. This is objective of the problem. Else print the solution is print no optimal solution exists. Okay, so this is Python's way of solving linear programming problem, integer linear programming problem. This is one of the famous algorithms in operations research. This algorithm is called Simplex. Okay, so let us run and see it. Okay, on one side we have single quote, on the other side we have double quote. So let us have same type of quotation on both ends. Let us run this. So what happened? Oh, I cannot apply this. It should be value of problem.objective and converted to integer. So total profit is 1660, which is a maximum profit. So one should produce 32 chairs and 34 tables to get it. Okay, hope you understood this. Keep watching and please subscribe. This is one of the most important problems of operations research and a real life problem as well. Thanks.